All right, check, mic check. Cool. We are live. My friends, welcome into another live stream. My name is Dr. Drew. And guys, this is Engineering Minds Juan. Welcome in. Good to see you. You're the first one in. Hello. All right, guys, we're a little bit later than usual, so we might jump right into it today. So guys, I think I'm gonna go ahead and jump right into it today. Let me go ahead and pull up the poll for the question of the day. Question of the day, which one are you? A, nucleophile, or B, electrophile? So let me pull up this poll real quick. So A is gonna be a nucleophile, and then B is gonna be an electrophile. All right. So guys, let's go ahead and get started for today. This is gonna be our live stream. What's going on, everybody? How are we doing? Let's get 40 minutes on the clock. Why does it say under review? Why does it say under review? Okay, let's get started here. My teacher is finally teaching the topic of SN1, SN2. Perfect, because this one is, that's exactly the topic we have here today. Guys, let's go ahead and start this quick poll because TikTok's not letting me do this poll. So let's try just a few minutes. Let's just try 5 minutes on the clock. Let's just put A and B. Which one are you? Let's see if it's gonna add here. All right. So let's put 5 minutes on the clock here and we're gonna run that back one more time. All right. So guys, let's just jump right into it. So guys, we have these practice questions. We're gonna jump right into, is it gonna be a nucleophile or electrophile? Cool. So for instance, this is our problem number 1 here. Give the products that you would expect to be formed in each of the following reactions. Nora, thank you for the love. Josh, welcome in. In each case, give the mechanism, SN1, SN2, E1, or E2, by which the product is formed and predict the relative amount of each, i.e. would only the product be only the product, the major product, or the minor product. All right, guys, so if this is U for organic chemistry, this is going to be SN1, SN2 substitution versus elimination reactions here. So this is a really common question that people ask about. And we're going to go through this one by one, lock in together. So first one here is we have 1, 2, 3. This is going to be 1, 2, 3. Okay, we're going to lock in for this problem here. CH3O minus. Okay, CH3O minus. And then we have methanol here. So notice we have an alcohol, okay, with the deprotonated form CH3O minus here. So the way we do this, we're going to do this step by step. And I'm working on a number of different guides and processes to make sure this is easy for everyone to understand. And so first we have this guide here. So guys, I just dropped this in the Discord in the chemistry section where you can download it for free. This is going to be the substitution and elimination reaction mechanisms guide here. So this is going to tell us whether we have SN1, SN2, E1, or E2. So if you want this guide, it's going to be in the Discord. All right. And the way this works is, first step is we have to identify if something is primary, secondary, or tertiary. So how do we know if something is primary, secondary, or tertiary? Well, we identify the leaving group here. In this case, our first example here, we have bromine is a halogen, that's the leaving group. So that leaving group is going to be our halogen, and is this going to be primary, secondary, or tertiary, Chad? Is this going to be primary, secondary, or tertiary leaving group? Let me know down below. So it's going to be primary, secondary, or tertiary for the bromine. How many carbon atoms, how many different R groups is it attached to? This substrate is going to be a primary alkyl halide here. So there's only one other chain that it's directly attached to. We're going to say this is going to be 1, 2, 3. This is primary. Very good. Your mom says primary. Giga Chad, welcome in. Yo says primary. Perfect. So the fact that this is primary, now now we have our base. So the first step is identify if this is primary. So this is not very sterically hindered. And then we're going to identify the base here. So notice I have a base. And the question is this going to be a strong base or a weak base? Okay, this is CH3O minus. and is going to be a relatively strong base, but not a hindered one. So it's going to be a good nucleophile. So guys, this is going to be a good nucleophile, and this is going to help us to lock in and determine whether or not this is going to proceed for SN1, SN2, E1, or E2. So guys, we're going to go ahead and do a quick poll, and let's cancel this poll. You know what? I just realized we can do this quick poll today. Let's cancel this poll, and let's see if this is what, let's see what everyone thinks about. So guys, let me cancel this poll. And so are you thinking this is SN1, SN2, E1, E2? So let's see. Is this going to be, okay. This reaction is, so let's change this. This reaction is A. You're going to say substitution. And then you're going to say B is going to be elimination. Elimination. So if you think it's going to be substitution, you're going to vote for happy face emoji. Okay? And if you think it's elimination, you're going to vote for crying emoji. Okay, you're going to vote for crying emoji. So, question: your mom says, "How do you know if it's a strong base or weak base?" That's exactly what we're going over today. By the end of this live stream, you're gonna understand perfectly whether something is strong or weak or good or bad. All right. So guys, we're gonna do a quick poll here. So let me pull this up here. Guys, wait 1 second until I pull up the poll. So let me bring this up real quick. And then if you think that we're doing problem A first. We're doing problem A first, chat. We're doing problem A. So let me cancel this. Okay. Let me stop this one. And then start a new poll. All right. So quick poll on the chat. You got 60 seconds. Start right now. So 60 seconds on the clock. So this first reaction A, do you think that this is going to be a substitution reaction? Vote for happy face. If you think it's going to be elimination, vote for crying emoji. So here we have a base CH3O minus, and then therefore we're going to see what it's going to generate here. Okay. So we see that it's going to be a good nucleophile and a pretty strong base here. Everyone is saying happy face. Martha's happy face. Annie happy. Liz happy. Brookie happy. And guys, so vote in the chat up on the top right hand side of your screen. So guys, one way is to memorize. So one way is to memorize. If you want to download the table, I just dropped it in the Discord. You can download this for free. So we identified this is a primary nucleophile, and then we see that this is going to be, for instance, a base. Okay. So this is going to be a nucleophile, and this is going to be primary. So therefore, it's going to be, as you can see, this is going to be SN2. Okay, this is going to be an SN reaction here. So this is going to be a substitution reaction. And so therefore, what's going to be the product, chat? What's going to be the major product here? So we're basically going to replace that bromine with O. So 1, 2, 3, OCH3. OCH3. So this is our first one. Guys, welcome into the chat. Isolation. Thank you for the rose. Guys, we are just getting started for today. My name is Dr. Drew. Anyone that is new here, welcome into the chat. This is our first problem. If you're new here, comment the word new. Okay, so that we know that you're new. And if you've been here before, make sure you comment that lock emoji, because you know we are locked in today. Chat, this is Dr. Drew with another live stream. We are just getting started today. You're watching Engineering Minds. And guys and gals, this is the website, engineeringminds.co. This is the place for you to drop in questions, join the Discord, and explore resources. I got you for STEM classes. Today's topic is going to be organic chemistry, but if you need any help for math chem, OChem, gen chem, physics, you can sign up for the Discord, which is totally free. Just go to engineeringminds.co. And you can also book tutoring. So again, if you need tutoring for Gen Chem, Math, OChem, Physics, I got you. Once again, that's engineeringminds.co. Chewy is new, April is new, MK is new. Welcome in, my friends. Guys, I go live every single week, Monday through Thursday. I typically go at 6 o'clock PST, but I'm quite late today. So today's 8 o'clock. So I'm going to go on for about an hour. I'm going to go on for about 90 minutes. So it's only been about 10 minutes. So if you're just joining in, we are just getting started. Here's our next reaction here. This is going to be 1,2,3 bromine with a tert butoxide. And guys, we're going to vote up on the top chat here. Vote if this is a substitution or elimination reaction. So last time, everyone cooked that up. Let's see how we're going to do again this time. Restarting, 60 seconds on the clock. So if you think this is a substitution reaction, you can vote for a happy face emoji. And then if you think it's going to be elimination, vote for that crying emoji here. Okay. And guys, if you think this is too late for you, if it's 11 o'clock for you, don't worry, because I'm going to be recording this and posting this up on my YouTube channel tonight. So make sure you hit that follow button so you get notifications for the next live stream. And sub to my YouTube channel. I'm going to be posting the answers tonight up on my YouTube channel. Okay, we got lots of happy faces. Happy, happy, happy. And guys, those of you that are asking if something is a strong or weak base, don't worry. We're going to be explaining all of that today, okay? We're going to be doing these example problems one by one. So in this case, what do we have here? This is 1, 2, 3. Our bromine here is once again our leaving group, but this time we have a base. So what's the difference between this base, chat, and this base? So guys, we have 3 seconds left on the clock. We got 9 votes for happy face. Okay, we got 9 votes for happy face and only only 1 vote for crying. Okay, so very good. So this is a bulky base. Okay, so therefore, if this is a primary, the first step is to identify if this is a primary alkyl halide here. So this is going to be primary. Okay, the reason it's primary is because it's only attached to one R chain here. So this is our giant R chain. And guys and gals, then we have tert butoxide. Tert butoxide, I want you to write this down. Tert butoxide, TBUO minus. This is a bulky base. Think of bulky as like, you know, it's like really, really big. It's going to cause steric hindrance. Very good. Okay, so then this is going to be our bulky base. And you know it's bulky because look up tert butoxide, my friend. Look up the image for TBUO minus. Look up tert butoxide. And then that's going to be causing a lot of hindrance. So therefore, it can't be substitution reaction, chat. It cannot be substitution reaction because imagine this bulky base is going to come in from the back to do backside attack. This will not occur. So that's going to be it's going to be too bulky. It's going to be too big. It's not going to fit in a way. Imagine it's going to like get blocked in the way. So this is not going to be a substitution reaction. This is going to be elimination. Okay, this is going to be an elimination, and in particular, it's going to be E2 reaction. Okay, so careful with that, chat. This is a tricky one. So bulky base is going to be E2 here. And therefore, if this is E2, we're going to go ahead and do that final product is going to be, well, basically the same thing. Kick off that, okay? And then it's going to generate that alkene group is going to be our final product. So Fisa says studying for Orgo 2 ACS right now. Guys and gals, once again, we are just getting started. This is Dr. Drew. And guys, if you need help with OChem, make sure you lock in. Guys, don't be watching this on your bed, scrolling on TikTok. That's not how to learn. Okay, the best learn is to actually follow along, get out your notes, and actually follow along. Like this is an actual lecture. Okay, part C is up next. So 60 seconds on the clock. If you think that this is a substitution reaction, you're going to vote for happy face emoji. Just tap that poll in the top left hand side of the screen. If you think it's elimination reaction, you're going to vote for crying emoji. Okay, so try to identify if this is primary, secondary, tertiary. You got 35 seconds left here. We got 4 votes for happy, 5 for happy, 1 for crying. And then we have HS minus here. So try to identify if this is primary, secondary, or tertiary. I'm sorry, but organic chemistry is such a what? Did you just say? For your major. What's your major, Swaggy? Okay, we got lots of votes for crying. And guys and gals, let me know what's your major down below. You can comment down your major if you're a college student, or if you already graduated, let me know. Or if you're not in college yet, what would you like to major in? So guys, this is gonna be basically a 1, 2, 3. So guys, is this primary, secondary, tertiary? So here's our bromine, here's our halide. So that's going to be our leaving group. And our alkyl halide is attached to, I see this as 1, 2 different different carbons here. So guys, we got 12 votes for happy. We got 7 for crying. So let's see how many we have here. And so this is going to be a primary, secondary, or tertiary, chat. This is primary, secondary, or tertiary here. Okay. So this is going to be a secondary reaction here. Guys, if you have problems, then go ahead and drop them into Discord. And if you want to join the Discord, it's totally free. Join up on the link in bio. And then, so very good. Sophia says secondary. It's not tertiary. No, it's not tertiary. And then this is going to be our HS minus here is going to be, okay, it's going to be a base slash nucleophile for HS minus. Okay, HS minus over here. So now what is going to function here? Okay, what is this going to essentially do here? Essentially, that's going to basically kick that off, okay? Basically, that's going to kick that off here and generate a new product. So the leaving group is going to leave and generate that new reaction here. So that's going to be our 1, 2, 3. So we basically replace that. Okay, but because it's backside attack, we have to switch the orientation. We have to switch the orientation, so we can represent that as a backside attack, just like this. Kick off that leaving group. So therefore, our proton now is going to be, our proton is now going to be a wedged compound, and then our dashed is now going to be our SH compound. So the correct answer was substitution. So if you said substitution, then you are cooking up today. If you said elimination, that's totally fine. Okay, just try to lock in. And once again, Chad, the best way to study organic chemistry is not to be scrolling on your bed. If you're actually following along and taking notes, go ahead and drop that lock in emoji to let me know that you're locked in. So let me know if you're actually taking notes and following along here. Okay, comment that lock emoji if you're actually studying here. And guys, if you have any questions, let me know. And so next one here is going to be D. 3 carbons to 4 carbons for B. Oh, I think I have a typo here. So 1, 2, 3. Let's see here. It's going to be 1, 2, 3. 1, 2, 3. So we have 1, 2, 3. Yeah, something's wrong here, chat. 1, 2, 3 here. 1, 2, 3. Guys, my apologies. This is going to be our double bond right over here. Okay, my apologies. So let's do the next one here. We're going to go ahead and do the next one here. And so guys, did I miss a question here? I thought it can't be SN2 because solvent is polar aprotic here. So guys, this is already going to be, this is going to be protic here. This is not aprotic. This is protic because we have HS minus, okay? So if it's protic, it's going to be SN here, SN2, okay? Yeah, sorry about that, Rami. I know. Okay, so then what we have here is this one's going to be part D here. So guys, who's ready to lock in for the next reaction here? Who's ready to lock in for the poll? So, okay, poll, you have 10 more seconds to think about it, and then I'm going to pull this up. So if you think it's going to be substitution, vote happy face, and then crying for elimination. Okay, starting right about now. 60 seconds on the clock. So once again, if you think that part D is going to be substitution, you're going to vote for happy face emoji. And then elimination is crying. So we got 3 votes for happy, 4 for crying. Lock in your votes. If you don't know, just guess. That's totally fine. And guys, let's go ahead and start to answer this problem. And guys, don't forget that I do go live every single week to answer your organic chemistry and physics questions. So if you want to join the Discord, make sure you hit that follow button and let me know your problems. The Discord is 100% free. You can join in, link in bio. So guys, what do we have here? Is this primary, secondary, or tertiary? Let's start to answer it once we're going through. So this is going to be our bromine is our leaving group here. And then this time we have OH minus. Ooh, OH minus. So we have a problem because OH minus is what? So OH minus is a strong base or a nucleophile. So guys, we got 9 votes for elimination. Let's see how we're doing here. And so what do we notice here? Well, there's all these different chains here. So it can't be SN2, right? Chat, do we understand why this cannot be SN2? Because we have no space for it to attack. So this can never be SN2, right? So therefore it has to be elimination. Okay, therefore it has to be elimination. So if you understand why this is elimination, then go ahead and drop that thumbs up emoji, okay? If you understand that this is elimination, go ahead and drop a thumbs up, okay? And if you don't understand, drop a crying emoji to let me know that you were cooked, because we got 9 for crying, so y'all are cooking up today. So if you voted crying, then you are good here. Okay, Classy says crying. So Classy, what don't you understand? This is a tertiary compound here. And so therefore we can't do substitution because substitution is going to get in the way. It's going to be like blocking in the way, right? Imagine that there's, let's do an analogy. Let's do an analogy real quick. So I like to think of OChem in terms of analogies. So this is you at a party, okay? So this is you, and your crush is over here on this side here. Guys, what's your favorite celebrity crush? What's your favorite celebrity crush? Go ahead and let me know your favorite celebrity crush down in the comments here. And then here's a group of people. Here's a group of people. So this represents tertiary because there's 3 people here in the way. So tertiary represents that there's 3 people in the way. Exactly. So if this is you and you're trying to get to your crush, well, they're blocking you. So you're never gonna be able to go through. So it cannot be substitution. That's why it has to be E, right? So let me know. So drop that thumbs up if that made a little bit more sense. Why it has to be E. So drop a thumbs up if that made sense. And if you understand this is E. So therefore, if it's E, we're going to basically deprotonate that. We're going to deprotonate that and then basically abstract that and then create an alkene bond here. We're going to put an alkene bond right over here. And guys, once again, if you want to download the notes for this section, we have the substitution and elimination reaction mechanism notes that are 100% free. I already dropped them in the Discord here. So guys, Liz says thumbs up. So guys and gals, if you have any questions, once again, you can join up on the Discord link in bio. Go to engineeringminds.co and then tap that link that says Discord so you can join in for free and download the notes for 100% free. And then you can ask your questions for OChem math physics. Okay. So guys, that's going to be our first reaction here. And so we have a question. What even is SN1, SN2? Well, we did SN1, SN2 on my YouTube channel. So just go back to my YouTube videos and look up my SN1, SN2 explanation here. We're doing a little bit later chapter, twin. We're doing elimination versus E1, SN2. Okay, so now we have this this one here. So once again, we have our bromine is tertiary, but this time we don't have anything. We just have methanol here. So guys, what is this gonna be? If this is methanol, is gonna be our last one here, chat. So let's pull up the poll one more time. 60 seconds starting right about now. So if you think that it's gonna be substitution, vote for happy face emoji, and then elimination, vote for that crying emoji. How do you know when to put a double bond? That's going to be for elimination, twin. So maybe we need to review the mechanism real quick. We're going to go ahead and review the mechanism right after this because I'm getting some questions about the mechanism. So people are like, what even is SN2? What even is SN1? Guys, let's go ahead and review the mechanism right after this. So guys, just go ahead and vote. 30 seconds on the clock. If you don't know, just guess. If you don't know, just guess. Wow, okay, y'all are cooking this up. So we got 6 votes for E. Okay, we got 6 votes for E and 0 for substitution this time. So guys, let's analyze this carefully. So this time we have an alcohol here. So guys, what's an alcohol going to be? Is that going to be a base, or is that going to be a nucleophile? So how do we know if something is a nucleophile or a base? Josh says OChem was the death of me. You know what Loki's saying? So guys, let's review if something is a nucleophile or a base. So for instance, okay, if something is, for example, an alcohol, which again, you guys can download these notes for free. So if something is, for example, an alcohol, it's going to be a series of reactions. It's going to be SN1, SN2, or E1 or E2, okay? So in this case, we have CH3OH. Once again, this is bulky. However, we can go out the we can do a shortcut. So imagine that you're trying to get to your crush, okay? And then one of the bodyguards leaves. One of the bodyguards is gonna leave, right? So then you're gonna like go. This bodyguard is gonna leave, and then you're gonna basically take advantage of the situation and go out the back door, and you're gonna get to your crush. Okay, so that's kind of like what the SN1 mechanism is gonna be. So actually, that's what we have in this case here. So basically, the leaving group is gonna leave first. Let's draw this mechanism, chat. So we're gonna have loss of leaving group first because now we have CH3OH. And then that's going to generate what's called a carbocation intermediate, chat. So everyone comment down below, carbocation intermediate. Okay, carbocation intermediate. You need to memorize this. It's spelled carbocation cation intermediate. And so this represented that the bodyguard your crush was being guarded by, he took a break. Okay, so now you're gonna come back and swoop in. You're gonna come back and swoop in and say, you know what, now's my chance. So you're gonna say, you know what, now's my chance. And then we need to do a couple more steps here. So let's go ahead and draw this step. And then you're gonna basically swoop in and try to get to your crush. Okay, but the only problem is you're a little bit too protonated, so we need to go ahead and deprotonate you real quick. Okay, we're gonna go ahead and use another copy of our methanol here. Okay, to deprotonate that because we have a positive charge here. So therefore, this is actually going to be an SN1 reaction here. So if you said substitution, you were cooking up today, okay? If you said elimination, that's all right, twin. Okay, I'm still proud of you. But next time, let's try to carefully identify what's our base here. Thank you, Nohemi, fellow UCR fam. How are you doing? And then this is going to be 1, 2, 3. Okay. 1, 2, 3, and then we have basically our OCH3 up on top. So that methanol basically got attached there. So at the end of the day, SN1 is basically you're with your crush. You got to be with your crush. You're together now. Okay, so that's how you can think of OChem, make it more fun. So once again, before we couldn't do SN2 because the bodyguards were in the way. The bodyguards were protecting your crush. Okay, but then once this bodyguard took a break, you basically said, hey, I'm going to take advantage of the situation and come out the back door. So that's what this mechanism represents. Guys and gals, is this making any sense? Okay, go ahead and drop a thumbs up if this is helping and you're actually understanding. Okay, and if you're not understanding this, go ahead and drop that crying emoji, but don't worry if you don't understand it yet. Okay, this is going to be a complicated topic, and we're gonna go ahead and break it down step by step. Do you have who did you have for the OChem series? Ooh, I don't want to say it on the live just in case. Okay, I don't want to say it on the live. Yeah, but they were pretty good, but it was just really hard. Okay, Classy says thumbs up. Mia, thank you for the follow. Welcome in. Ivams, thank you for the rose. Does the temperature matter? In this case, the temperature was not specified, but that's a really good question. Let's talk about if we have temperature involved here. Okay, let's talk about if temperature was involved. And let's go ahead and pull some of these examples up here. So I already dropped these in the Discord, and so we're going to work on these together. So this example says your task is to prepare styrene by one of the following reactions. Okay, which reaction would you choose to obtain the better yield of styrene, and explain your answer. Okay. And yes, we're covering alkenes today, twin. So on the left-hand side, we have one that is KOH, ETOH in heat. And we have this primary, okay, we have this primary alkyl halide here. But then this side, we have secondary, okay, everything else being the same. So guys and gals, what are we thinking here? Let's discuss this together one at a time, and let's try to figure out, deduce which one is the correct answer here. So okay, so what do we notice? We notice that all the substrates are a little bit different. This one is primary on the left. So chat, do we understand why this one's primary? Do we understand why this one's primary? It's primary because it's attached to only one giant R chain here. Okay? You think I can learn orgo as a high schooler? You can self-study a little bit of orgo. You can self-study a little bit of orgo for sure, but you probably need a little bit of Gen Chem first. You need to understand the concept of equilibrium for organic chemistry. As soon as you finish equilibrium in Gen Chem, you can definitely self-study orgo. Okay, but it's a little bit less common. I don't hear too many high schoolers doing orgo, but it's definitely possible. And then chat, what else do we have here? So styrene, and then we have KOH. So chat, is KOH a strong acid or a strong base? Do we have acid or base here? What is this going to be? Is this going to be a nucleophile attack or a substitution reaction, chat? Okay, so we're going to go ahead and pull up that poll one more time. So 60 seconds on the clock starting right about now. So based on this reaction, do you think that E is favored? Okay, if you think that this is a substitution, vote for happy face emoji. And if you think that this is elimination, vote for a crying emoji, okay? So guys, make sure you vote up on the top left-hand side of your screen. And if you don't know, don't even worry about it, okay? Just pick a guess. There's no wrong answers. Okay, so notice the product. What is the product here? If you said substitution, please let me know why you said substitution. If you said elimination, please let me know why you said elimination here. So how do we know if it's strong or weak? Okay, so let's address that because people keep asking that. I'm not really addressing that yet. So let me give you one example. Remember, NaOH. So remember, you're not bad at OChem. You just kind of forgot a little bit about your Gen Chem. So remember, chat, what is NaOH? So forget OChem to the side for a sec. What is NaOH? What about KOH? What is KOH? How is that gonna, how would we write, let's pretend this is a Gen Chem class. How would we write the equilibrium dissociation for Gen Chem here? Okay, for KOH and NaOH. Okay, well, we recall that sodium is a group 1 alkali metal, which has what kind of charge? It's going to have a positive charge, right? So we're going to have sodium metal, which does not react. By the way, cations are very low, like they're not very reactive here. And then we're going to have OH minus is a highly reactive species here. And then similarly for KOH. So KOH, I'm seeing this as like a really strong base, chat. Okay, this is a really, really strong base. How do I know it's a strong base? Because like Gen Chem logic, you're not bad at OChem, you're not confusing OChem, you're just forgetting your Gen Chem. That's how I see it. So remember, a KOH is going to fully dissociate and generate a crap ton of partial, a crap ton of hydroxide ions. Okay, so remember, the definition of a base is anything that produces lots and lots of hydroxide ions. Exactly, right? Kaylani says yes because of OH, right? Exactly. So therefore, we need a strong base here. And so what do strong bases love? Chat, everyone comment down below. What do strong bases love? What do bases typically absorb? What do strong bases typically, like, what do they typically bond to? Okay, are they going to bond to carbons or going to, exactly, positive charges? So they're going to basically get that proton. Okay, strong bases love protons. They're going to steal that proton. And what's something that's going to steal a proton? That's going to be E. Okay, so the correct answer was E. So if you said E, you were cooking up. And then this is gonna be the elimination product. Okay, this is going to be E2. So everyone keeps asking me to show the mechanism. So let's show the mechanism. Let's see what's going to happen here. So the very first step is, guys, we're going to generate base here. It's going to be OH minus. Let's generate that base, drop the base. Okay. And then chat, we only have one option here. So we're going to basically use our OH minus to eat this proton. The OH minus is going to yum eat this proton and then create a double bond onto this line, single bond line, and thereby kicking off the leaving group. E2 is a concerted process, meaning this all happens in a dance, in a really quick step here, and it's going to generate 1 2 3 4 5 6. Our benzene ring does not change. We have 1 2 3. That's going to be our elimination product here. Chat, let me know if that's making sense. Okay, if this is actually making sense and you're learning today, go ahead and drop that thumbs up emoji. Okay, if you're actually understanding this, go ahead and drop that thumbs up emoji and let me know if this is clarifying that. If you're still confused, drop that crying emoji to let me know that we're still cooked. Have you covered mass spec? I have not done mass spec, but I've done IR in the past. We can definitely do mass spec and IR. We've done that like twice in the past. We can definitely go over that. Okay, thank you. Kaylani says thumbs up. Yeshua. Okay. Is it always 3 arrows? Is it always 3 arrows? For E2, yes. E2 is going to be that concerted process where we have the proton transfer. Okay, that's going to be the proton transfer. And then the simultaneous, donating of this bond to create a double bond. And IDK about you, Chad, but I think my double bonds are always blue. I think my double bonds are blue and my benzene ring is low-key kind of blue. Okay, I don't know about you, but I see like double bonds, alkenes, as like blue. Okay, so therefore this one is not likely to occur. Okay, because we have basically steric hindrance here. Okay, we have steric hindrance. Now, and then we also are missing, let's see, we also have one of this, let's see, this product. Wait, let's double check that this is going to be possible here. So it's going to be E2 secondary. But wait a second, we're not done, chat. So this one is still possible, but I think this one might be possible as well, chat. So chat, another example. Okay, let's try that again. So I take it back. So we're going to do this one here. And then chat, we're going to basically use our OH minus here. Now we're going to abstract from another side over here. Let's say we're going to get this proton here. We're going to get this proton over here. So I'm going to go ahead and eat this proton, yummy, yummy, and then donate that and kick off the leaving group. Thereby, we're going to generate what as a product? We're going to generate what as a product is going to be a cyclo. We're going to have a benzene ring and kick off the leaving group. Okay, we still have the product there. So therefore, that's going to be our KOH. But the secondary is going to be desired, actually. Because actually, this will be SN2. It will be also possible here. So another possible mechanism, let's try one more. Let's try one more example here. Because another possible mechanism is our KOH is actually not only going to act as a base, it's actually going to act as a nucleophile. So our KOH, another possibility here is going to be our KOH, okay, our OH minus is going to come in and, okay, basically kick off that and generate, okay, essentially a different product here. Okay, that's not what we want, chat. That's not what we want. So we're gonna say that this elimination, this substitution reaction is less is gonna make this one the less favored reaction because we want this as a product here. Okay, we want this one as a product, so that's why we're gonna go with the SN with the E2 mechanism here. How do you keep yourself motivated to study when you're at a high level, guys? That's an open question for anyone. So comment down below. How do you keep yourself motivated to study when you're at a high level? For me, I find motivation from the math because I really like math. And I find motivation from doing physics and math problems. What about y'all? Okay, what about y'all? Guys, let me know if this is helpful. We're going to do another reaction here. We're going to do another example. Classy, thank you for the follow. Thank you for the love. Let me know if there's any questions. You can drop them down below. And guys, we're going to just keep doing example problems here. And let's continue to identify what are the best ways to memorize strong acids versus strong bases, and then strong nucleophiles versus strong bases here. Okay. Classy says, I actually hate the math portion. I love solving puzzles with Orgo. Oh, nice. Okay, so you actually like organic chemistry. Perfect. So guys, we're going to try this problem next. It says, write the structural formulas for all the products that would be obtained when each of the following alkyl halides is treated with sodium ethoxide and ethanol here. So sodium ethoxide with ethanol. So we're gonna have to carefully go through each of these one by one, and then when more than one product results, you should indicate which product would be major and which would be minor products. You may neglect cis-trans isomerism of the products when answering this question. Okay, so this book is from Solomon's. This is by Solomon's 13th edition, and then once again I dropped these problems into Discord, and again I am recording this, gonna post this up on my YouTube later today. All right, so here we have our first one. We're gonna go ahead and draw that first reaction. Here is gonna be, okay, bonus points if you can name them too, if you can name the reactant and the product. And so first we're gonna do sodium ethoxide. It says heat with sodium ethoxide, NaOET, and then also ethanol. Okay, so we have sodium ethoxide and then ethanol. You pretty much have to memorize that, chat. You pretty much have to memorize this is NaOET. Okay, this is sodium ethoxide, and then this is ethanol. You pretty much have to memorize that. There's no way around that, okay? But also try to understand as well, okay? Sodium ethoxide, OET. Okay, so chat, what are we feeling here? What are we feeling? Is this going to be SN1, SN2, E1, E2? So let's go ahead and pull up that poll one more time. So if you think that it's SN1, if you think it's substitution, vote for happy face. And if you think it's elimination, vote for crying emoji. 60 seconds starting now. And again, if you don't know, just guess. Okay, so chat, what I'm thinking here is, first step, let's identify excuse me, the alkyl halide here is our bromine is our halide. And then what are we gonna say next here? We have 1, 2, 3 here. So I see that we have one group here and then another group here, so I'm gonna label this as secondary. So as soon as I see secondary and then as soon as I see OET, okay, I'm gonna call this as a base. I'm gonna call this as a base. And then chat, let's go ahead and just double check. You can go ahead and use the table. And we see we have secondary is gonna be the E2 major product and SN2 minor. So we're actually gonna have two reactions here. So we're gonna have two reactions. Think of it as an alternate universe. So in one universe, we're gonna go with E2 is the major product. Okay, so in the first universe, we're gonna say E2 is the major product. And then in the alternate universe, we're gonna say that SN2 is the minor product. So let's start with the major one. And so for the major one, we're basically gonna go ahead and deprotonate. Now we have a couple options here to deprotonate. Let's see if we have one over here and then one over here and one over here. So I'm gonna go with the one that is gonna be more substituted. So I'm gonna basically deprotonate. Let's see here. So I'm gonna deprotonate. If I deprotonate this guy here, then I'm going to create a double bond here and kick off that leaving group. So I'm going to generate 1, 2, 3 double bond here, and then create an alkene like that. That was a little bit ugly. Let me make this a little bit better. So we got 2 votes for E2, and we got 1 vote for, no, we got 2 votes for substitution and 1 for elimination. Thank you, chat. And this is going to be 1, 2, 3 double bond just like that. All right, chat. So then this is going to be our first product. This is going to be our major product. So if you said elimination, then you are technically correct. Is elimination is the major product. But also, can we do substitution? We can do substitution. I'm thinking we can even maybe do SN1 maybe. So this is going to be secondary. According to the table, okay, according to the table, it says we can do SN2 as a minor product. So SN2 is a minor product, which again, hopefully that makes sense because we can basically say that our OET minus is going to come in from the back right over here and then kick off that leaving group. All right, and then generate that as our new product. 1, 2, 3. Okay, just like that. And we have our OET. We have, let's see, that's what that was. Okay, that's going to be, wait a second. Let's go back for a sec. We kind of have, so this is 1, 2, 3. So this is SN2 minor. Yeah. So I'm gonna just redraw that. This should be OET, but this is gonna be a not favored. Let's just say this is not favored. Okay. This is just not favored because it's too bulky here, chat. So anything that is bulky is in the way is gonna block that substitution reaction from occurring. Okay, and so therefore we can also generate another product as the other minor product for E, which would basically be if we had an alkene on this side over here, namely if we deprotonated the other alkene bond over here. Okay, so this is our first example. Let me know if that's making sense here. Organic chemistry is going to be the death of me. Not if you lock in, my friend. Not if you lock in. Hot fries. Thank you for the share, guys. And how are you feeling about this problem? How are you feeling about the semester? I know it's that time of the year where it gets a little bit stressful because of midterms and finals. Are we still surviving, chat? Are we still feeling good about the semester, or are we feeling low-key cooked? Let me know down below. So guys, I'm going to go ahead and do the next example here is basically this one. So let's draw this one. And once again, if you're new here, let me know what's your major, what are you studying? Are you currently taking OChem or you're about to take organic chemistry? Okay, let me know if you're feeling good about this topic or feeling absolutely cooked about this topic. I passed. I wouldn't repeat organic chem though. Surviving but ready for break. Awesome. What do you do as a chemical engineer? Do you mean me specifically or in general? In general, chemical engineers can go into a number of different fields, including processing or biotechnology or environmental work or, um, you know, analytical chemistry, fluid dynamics, like lots of different options. So we have NaOAT. Me personally, I was in the environmental sector and I did research for about 7 years in environmental engineering slash water chemistry. Okay, so once again, we have NaOAT. We're about to lock in for this example. Cooked as in Ludo. I think if you put an exam in front of me, I will be lost. It will be, I was like that in the moment. It would get, then it would slip my mind by my exams. Low key same. Low key same. If it slips your mind, that's telling me that you're gonna be not you're basically have to like review more. You need to do more review problems. So that's exactly what we're doing right now. We're doing a review every single week to lock this in. So chat, how are we feeling about this one? Do we think this is gonna be SN2? Do we think it's gonna be substitution or elimination? So if you think it's gonna be substitution, vote for a happy face emoji one more time. And if you think it's gonna be elimination, you're gonna vote for a crying emoji. So chat, I just realized, I think all of these, does it say some of them could be substitution? Some of them could be substitution, but most of these are gonna be elimination. Did you ever use Orgo during your research? I did not. I'm an inorganic chemist, chat. I'm an engineer and I'm an inorganic chemist. I did not do organic chemistry, but I did do inorganic chemistry because I studied nitrate photolysis. Okay. Substitution because carbon was a leaving group. Okay, so let's check that out. Okay. And then, guys, this is going to be 1, 2. Okay, this is going to be another secondary. So, guys, always identify if it's primary, secondary, or tertiary. So this is going to be secondary. So how do we know that it's secondary, chat? That's why I use the colors, chat. Okay, this is why I use the colors. So on the left-hand side, that's one compound here. That one's in green. And on the right-hand side, I see this entire structure is a different color. That's why it's called secondary. Okay, because our alkyl halide is gonna leave here. For some reason, the live broke for me. It's all super blurry. Oh, is that? Oh, chat. Do we have any technical issues? Is it good now? Okay, thanks for letting me know. I wonder if that was for everyone or just for some people. And guys, so that's gonna be NaOAT here. And then what are we gonna do, chat? So are we going to, how are we feeling? Do we want to eat a proton or do we want to kick off that leaving group? So someone said substitution, and because it's secondary, I think that's also possible. SN2 will be the minor product. So we're gonna make a copy of that and we're gonna do a substitution. So if you said substitution, you're partially correct, okay, because that's gonna be a minor product. I think here my book says only E. So guys, let's analyze why this is not correct. So my book says I want to do substitution here because I want to do a backside attack and loss of a leaving group here. And let's generate this product here. Okay, but I think this is not going to occur, chat, because this is too bulky. This is too bulky, so this is not going to actually occur. Okay, this is what I mean by bulky. When something is like really long and the arms are kind of like going chaotic here, that's going to be too bulky, chat, and that's going to be basically not gonna occur, not likely, like not likely to occur. Okay, so rather we're gonna do elimination one more time. And chat, we don't want to go from this side. We can't get any protons here, so we have to get the proton from this right hand side here. So we're gonna get this proton all the way on the right, I mean on the left, and then generate that using our E2 mechanism. So that's gonna be our kicking off that and generate our final product just like that. Okay, chat, how are we feeling about this example? Do we agree that this is the major product? This is the only product, and the other SN reaction is actually not likely to occur because it is too bulky. Okay, so of course, now it's just me. I live in a field. Got you. So question, what is the point of sodium in this case? Is it just a catalyst? No, that's a really good question. Sodium is not a catalyst. It is the cationic form of the salt. Remember, ethoxide is going to be our anion, so that's what's going to be react. So let's talk about that real quick because that's a really common question. So what about NaOH? So remember, NaOH is a salt. How do we know it's a salt? Because remember your Gen Chem chat. So this is going to be a cation. This is going to be an alkali metal, a group 1 alkali metal. And then this is going to be, well, that's going to be our anion. Okay, so this is going to, in equilibrium, dissociate to generate a cation, Na plus, and your anion, OET minus. So OET minus, just like that. So that's going to be your cation and your anion. So that's why it's going to be NaOET minus. And so the cation just serves it doesn't serve a function. It's just, that's the form. So it doesn't serve a function in this case. You can still get substitution on secondary alkyl halides. Textbooks are inconsistent on this issue. Oh, thank you, Ryan. I was wondering that. Yeah, I was thinking like technically it could be possible. I wonder if there's literature on this because now I'm curious. How do we know if it's gonna be forming or not? Because yeah, I noticed that sometimes we do have SN2 here. Appreciate that. So it's weird how E is super favored because a terminal alkene is produced. I would assume it's SN. Even though it's a terminal alkene, it's still gonna be favored compared to our SN2, mostly because of this bulky chain here. Okay, and these are some really good questions, chat. Appreciate y'all. And guys, let's go ahead and move on to the next question. And okay, let's go down to the next one here, which was what? So the next one was C. So we finished A and B, and we're going to go to C and answer this one together. So I see 1, 2, 3, 4, 5. So I see 1, 2, 3, 4, 5, and then a bromine on the bottom there. Okay, with another methyl just like that. All right, chat. So again, the reactant doesn't change. It's going to be NaOET is still going to be the same compound here. But now we have to identify what's the product this time here. So how are we feeling about this one? Do we think it's going to be another elimination reaction or perhaps both? Okay, or perhaps both. So once again, if you forget, you can go to the table and we have to identify where's the substrate here. Our bromine is going to be our leaving group on this substrate. Is this going to be primary, secondary, or tertiary here? This is going to be primary, secondary, or tertiary, chat. What are we feeling? Okay, so I see that this is going to be attached to 1, 2, 3 different chains. So there's going to be 3 different substituents there. That's going to be a tertiary alkyl halide. Then Ryan says it's pretty substrate dependent. The website Master Organic Chemistry has a good article explaining it. Interesting. User says tertiary, very good. Kaylani says primary. So it's not going to be primary twin because we have 3 different things attached to our bromine. So let's try some different colors here. I'm going to color this one in green. I'm going to color this one in orange, and this one is going to stay as yellow. So that's why we have 3 different substituents. That's why it's going to be tertiary. No beta carbons, can't be E2. So it can't be, let's see here. We do have some beta, don't we, though? Why do you suggest we don't have beta here? So we do have some beta ones here. Okay, I see some beta protons right over here. This is H. Okay, H over here and H over here. Remember, the first carbon over, that's our alpha carbon. And then our next carbon over is beta, beta, and beta. So we do have 3 beta carbons. And then, by the way, the next carbon over is going to be alpha, beta, gamma. So then that would be our gamma protons. But we're not going to worry about those right now, okay? So beta carbons are the carbons that are 2 over from your halide here, okay? So therefore, chat, I'm thinking we're going to basically absorb one of these hydrogens, and then we're going to generate 2 products here. So let's make a copy of this, and I like to think of it in terms of 2 different variations. So in one universe, we're going to attack one of these protons here, okay, and then kick that leaving group off just like that. And in another universe, we're going to attack this proton and then kick off the leaving group just like that. All right, perfect. So let's see what's the final product on this side, chat. So on the final product on this side, we're gonna have basically 1, 2, 3, just like that. And then this is gonna be an alkene here. Let's see, this is kind of funky looking here. So our alkene will be like this, and then this is gonna be kind of down like that. Okay. So let's see, this is kind of funky. I'm not sure if that's right. Something kind of funky there. Let's try the bottom one real quick. And then this one's going to be R1, 2, 3, 4, 5. Okay, there we go. So this one is our alkene here. So remember, elimination reactions are always going to form alkenes. Yeah, I think that's right here. I think that's right. Okay, you like LeBron or not? I'm not gonna lie, chat. Like, I like the Lakers, but I'm not like a big sports person though, guys. I'm not gonna lie. But who do you guys like? Okay, do you like LeBron? I love that you're doing this. Thank you, Mikey. And what is our solvent? Is NaOET. Okay, is NaOET. Oh, good question. It's in MEOH and heat as well. Ethanol. Okay, our solvent is ethanol, and it's gonna be ethanol down over here. Okay, so one of these is going to be the major product, and then which one's going to be the minor product? So actually this one's going to be the major product, okay, and this one's going to be the minor product. Okay, and very good. So guys and gals, let me know if there's any questions here, and let's try to contemplate which one would be major and minor. Okay, because LeBron is the nucleophile of orgo. Wait a second, that totally flew by me. LeBron is that BR? Bro, LeBron. Oh my gosh, that totally flew by me. Okay. So SN1 is gonna be no, it's not gonna be SN1, it's gonna be E still. It's still gonna be E, and it's not racemic. Okay, it's not racemic, chat, because we have OET is gonna be basically attacking some of those. And this is gonna be tertiary here. Okay. I didn't get the LeBron joke, homie. Well, because like bromine is everywhere. So someone else said that. Can user explain the joke, please? So bromine is everywhere. We have LeBron everywhere. All right. Major, minor, carbocation stability. Yeah, but this is not going to be for SN, or it's not going to be for SN1 or E1. It's only going to be for E2. It's going to be one step here. Okay, it's going to be E2 here because we have, let's double check that. So we have tertiary. Yeah, so tertiary is E2 only, chat. Okay, tertiary is E2 only. So we're not identifying carbocation stability. Carbocation stability only occurs for SN1, E1. Okay, I get confused on how reagents and alkenes, and I don't know what reagents you use. Well, typically the reagents are given. Are you asking about synthesis? Why did you not attack the H on the orange line? Good question. Why did I not attack the H on this side, chat? Okay, because these are identical protons. So even if I did it on this side, okay, even if I did it on this H, on the orange one, then those would have been identical products anyway, because those protons are gonna be identical. Angie says IDK switched majors. Does this have anything to do with bond dissociation energies? Indirectly, in a way, yes, but not really. That's kind of a different topic, but yes, there's some theory there. So if there's some theory, then we can always talk about the theory, but not really. We're just talking about the reactions themselves. Braun the nucleophile attacks the rim very. So there you go. That's the explanation for the joke. The person that was asking about the LeBron jokes. Braun the nucleophile attacks the rim. Tertiary is E2 only. What if my solvent is protic or aprotic? Okay, so chat. So this is where the table comes in. So once again, if you want to download the table, it's 100% free. And guys, we can use the table. So if we have a nucleophile only, that's going to be SN2 or SN1, depending on if it's primary, secondary, or tertiary. If we have a base only, that's going to be E2. Okay, for all primary, secondary, tertiary. And then strong base is going to be E2 minor or SN2 major, E2 major, SN2 minor. And then finally, we're going to have primary, secondary, tertiary for SN1, E1. And then, yeah, guys, and then finally, that's going to be our 4 conditions here. So once again, if you want to download the table, it's 100% free. Just tap that link in bio, go to engineeringminds.co. And guys, you can join the Discord for 100% free. That's where I drop the table. So go tap the link in bio, engineeringminds.co. Go down a little bit to where it says join Discord. Click the link, click join Discord. And then, guys, if you need any tutoring, I got you. Okay. You can book a session. The first one is 100% free. So click that link that says book a session. And then I got you if you're taking Gen Chem, OChem, Math, and Physics. And once again, guys, the Discord is free. So there's no reason why you shouldn't join. So that's where you can get the free resources that we're discussing today. And guys, we're not done yet. We're gonna keep it going for about 30 more minutes. So guys, if you have any more questions about OChem, Gen Chem, Math or Physics, drop them down below. And guys, let's continue doing these example problems. Our main topic though is substitution versus elimination reactions. So we're gonna keep doing these example problems and basically locking in. So please, please, please let me know if you have your exams coming up for this topic. And guys, let's do our next example problem here. So the next example problem is going to be, okay, let's take a look at this one here. So it says, which products would you expect to obtain from each of the following reactions, SN1, SN2, E1, or E2? So this is going to be the perfect opportunity for us to practice SN1, SN2, E1, E2. Okay, so what was the answer? Oh, the answer was, this was the major product twin. The answer was E. Okay, I thought I made that clear. Okay, the answer was E here. Okay, this is going to be E2 here is the major product. Okay, so guys, we're going to move on to the next example here. Okay, Lonnie says exam 4 and finals soon. Okay, finals. When are your finals, my friends? So guys, we're going to do number A. We're going to do 37A here. We're going to go on for about 25 more minutes here. And let's go one at a time. So we did one similar to this. So notice we have bromine here is our alkyl halide. So here's how you answer these ones, chat. Here's how you answer these problems. So, oh, sorry, I was talking about being substitution or elimination. Elimination. E stands for elimination. E stands for elimination, twin. Elimination. Okay. So guys, we're gonna do this one together. And guys, let me pull up. We're gonna do number 1 first. A. So guys, a quick poll active in about 5 seconds. So you're gonna vote for happy face if you think A is substitution, and if you think it's elimination, vote for crying emoji. 60 seconds on the clock starting now. So we're doing problem A first, guys and gals. So if you think that problem A is an elimination reaction, you're gonna vote for crying, and then SN for happy face. Okay, happy face is substitution, crying is elimination here. Okay, so how are we gonna do this, chat? We gotta lock in. So we're gonna do this by identifying how many our alkyl halide, if that's primary, secondary, or tertiary. So our bromine lives right over here, and that's our alkyl halide. So is this gonna be primary, secondary, or tertiary, chat? So very good. So we got 10 votes for E and 3 votes for SN. Y'all are cooking this up. So let's answer this together. So is this going to be primary, secondary, or tertiary? Okay, so I see that we have one long chain here. That's going to be a primary carbocation, primary alkyl halide rather. And then we're going to have our ETO minus. Chat, what's your favorite color? Drop it down below. I need to switch up the colors. Chat, go ahead and drop down your favorite color down below in the chat. And I'm just going to go ahead and use this purple guy here for our ETO minus. So chat, is ETO minus going to function as a nucleophile or a base here? Is it going to function as a nucleophile or a base? User says purple, red, green, purple, pink. All right, awesome. So guys, then this is going to be our final product is going to be, let's go ahead and see how to do this. So there's going to be a 1, okay, it's going to be 1, 2, 3, 4, 5. Okay, we have 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and then our BR here. And redrawing that real quick, we have our OET minus. So what I think is going to happen, chat, right, is because this is going to function as a nucleophile. Okay, that's the most common question I'm getting today. How do I know if it'll act as a base or nucleophile? So guys, if this is a primary alkyl halide, well, again, chat, remember, think about the nucleophile as U. Okay, this is U. And then this is you trying to get to your crush. Okay, so right now this is U. Okay, this is U. Okay, and then this is your crush. So chat, go ahead and let me know who's your celebrity crush one more time. So comment down below who's your celebrity crush. Who's your favorite celebrity crush? And don't be shy. Okay. Who's my favorite celebrity crush? Let me think about my celebrity crush real quick. Okay. And then we have our bodyguards here. So right now this is only primary. So we only have one bodyguard. So I'm going to get rid of this. So you're going to have no problem coming in to the back side here, okay, and getting to your crush. So that's going to be analogous to our SN2 mechanism here. So you're going to have no problem because that's primary. Okay, Madison Beer. Ooh, that's a good celebrity crush. Okay, so this is Madison Beer and this is us, chat. So we're trying to go talk to Madison Beer, and we can just simply go through the back door because there's only one bodyguard here. So he's not going to be in the way. So we're going to go through the back door, and so therefore that's going to be called SN2. Okay, SN2 is substitution. Okay, so therefore we're going to go ahead and attack, do a backside attack just like that, and then kick off the leaving group. So then the bodyguard is gonna be gone. He's gonna be gone here, and then we're gonna basically form our new product. We're gonna have 1, 2, 3, 4, 5, 6 OET, just like that. So that's gonna be our methyl ethyl, just like that. So the correct answer was SN2. And then, guys, we got 10 votes for E. Unfortunately, twins, that is not correct. Okay, we got 10 votes for E, but don't worry. Okay, I believe in you. Thank you. Appreciate y'all. Okay, why Madison only have one bodyguard? SN2 and not SN1? Okay, fine. Then it's not Madison Beer. Then we need someone else. Okay. And then when will it be a base? So it's going to be a base if it's a really strong base where there's too many bodyguards. Okay, there's too many bodyguards. So let's try to find another example. So then that's going to be our SN example. So guys, let's go ahead and find another example. Let's see if this one's going to be, if this is going to be a base or an acid here. So guys, go ahead and we're going to do problem B for next. Okay. So everyone take a look at problem B. You have about 20 seconds to think about it. Is this going to be substitution or elimination? Is this going to be substitution or elimination here? Okay. And then guys, while you're thinking about that, 10 more seconds to think about that. I need 3 characters. I need a person that's going to try to rizz up someone. Okay, I need some bodyguard analogies, and I need a celebrity crush. Okay, 60 seconds on the clock starting right about now. Oh wait a second. Hold on. Why is this not letting me do it? 60 seconds starting. Wait, hold on. It's not letting me do it. Hold on. Okay, we might have to cancel the poll. Okay, I'm getting a TikTok glitch. Hold on. Okay, no poll chat, so just comment down below. So happy face for substitution, and then crying emoji for elimination for problem B. We're doing problem B here. Okay. So guys, we need some analogies. So I need some characters. So give me a Riz character and give me a celebrity crush. Okay. I'm on my day off and I see this. I rebuke. I'm sorry, Kat. I'm not really sorry. Okay, guys, the poll's not working, so just comment down below. So if you think it's elimination for problem B, vote crying for elimination, happy face, substitution here. Okay, and Nico says, crying. Some period says me and you. Let's try the poll one more time, chat. TikTok's not letting me pull up the poll for some reason. Okay, no more polls for today, unfortunately. So guys, we're gonna go ahead and answer it anyway. So we have 1, 2, 3, 4, 5 carbons. So let's see what's gonna happen here. So let's see what's gonna happen. We have 1, 2, 3, 4, 5 carbons with the bromine. And this time we have terbutoxide. So terbutoxide, I want you to think, chat, okay, be respectful now, but I want you to think of a character. Be respectful, otherwise I'm gonna mute you. But think of a character that's really, really big. Okay? Think of a character that's really, really big. I'll go first. Shrek. Okay? Shrek is really, really big. Alright? So that's gonna represent a really, really bulky base. So this is terbutoxide, and then this is gonna be our really, really bulky base here, right? Okay. All right. Classy says I'm starting to kind of get it. Awesome. And then chat, how many bodyguards do we have on this side here? How many bodyguards do we have here? This is gonna be third here. Okay. Someone says Barney, Jinbei. Oh, Jinbei from One Piece. Bulky base equals a strong base. The giant from that One Kid story. There you go. So all your bulky bases, think of like the biggest character you can think of. Okay, I'm thinking of like Shrek and like anyone that's like really really big. So bulky base is like huge, my friends. Like it's never going to. It's gonna be too big. It's not gonna. Okay, it's not gonna like, you know, it's not going to fit, so to speak. Okay, so bulky with minus charge equals a strong base. So we're not done yet. Okay, we're not done yet. So what's going to happen? Let's look at a picture of terbutoxide. Let's look at a picture of terbutoxide so we can fully understand and visualize what's going on here. And I'm low-key blanking out on the chemical structure, so I want you to memorize this structure, chat, for terbutoxide. Okay, try to memorize the structure for terbutoxide. And guys, this is what terbutoxide looks like. Okay, imagine that this is the biggest character you can think of, and for me, I'm thinking this as like Shrek. Okay, so this is terbutoxide. It's so bulky. It's like, oh my god, it's so big here. Okay, and then this is gonna be O minus here. So guys, what's gonna happen is like, okay, Madison Beer is our crush, right? This is Madison Beer, and she only has one bodyguard. Okay, but if we're trying to go from the back door, if we're trying to go from the back door here, we're so big because Shrek is like, he's so big. How is he gonna go through the back door? He's not gonna fit. He's trying to like sneak his way. So how is he gonna like sneak his way? Okay, rather he's gonna just go in and just basically demolish here. Okay, so this is gonna represent bulky base. Okay, and this is Madison Beer, so he's gonna just go ahead and basically eat the bodyguard. Okay, so that's gonna be represented as eating the proton here, and then our bulky base is gonna go ahead and come in and generate an alkene, our alkene over here. Okay, just like that, and kick off the leaving group. So he literally just like Hulk smashed the bodyguard here, and now Shrek is happy because now he's in a relationship with Madison Beer. Okay, and that's gonna be our final product, just like that. Chat, is this making sense here? Is this making sense? So let's see what's our final product. If this is making sense, drop some thumbs ups, emojis. Okay, so that's gonna be our final product, just like that. It's gonna be E2 because we have a bulky base. It's gonna basically eliminate. Is gonna eat the proton. So it's always gonna be the beta carbon. Yes, it's always gonna be the beta carbon, classy. It's never gonna be the alpha carbon. It's always gonna be the one that is. It's never gonna wait. I take it back. It's always gonna be like the one. I think I made a mistake now that I think about it. Shoot. The previous one, I labeled that one as alpha. That one's going to be our carbon here. So it's always going to be the one that is... I got the alpha carbon this time. Okay, I need to double check the alpha carbon here. But typically it's going to be the one that is one away from the bromine. Okay, I gotta double check that. I'm sorry, classy. I gotta double check that, and then I'm gonna drop it in the Discord later because that's a really good question. So Smiley, thank you for the love here. Secured the huz, exactly. Can we use any one of the two hydrogens in that specific carbon? Yes, you can. So you can use this hydrogen, and like you said, we can also use this H as well. Doesn't matter. If no beta carbons is available, we can't be E2. Exactly. So if there's no protons available, then we can't do E2. I have a 64% right now, and I have a midterm today. Okay. Do C, please. Smiley says do C. Okay, let's keep it going, chat. Let's keep it going. And guys, of course, and guys, let's keep it going. So let's see what it's gonna be next, and let's see if TikTok brought back my. I don't know what the glitch is here. There's like a glitch in the system. There's a glitch in the matrix. And once again, guys, I am recording this, so if you want to rewatch the whole live, I'm gonna be posting this up on my YouTube channel tonight. Okay, no more polls for the rest of the night, chat, unfortunately. So just comment down below. We're gonna do C next. Okay, we're gonna do C next. So if you think that C is a substitution reaction, if you think that C is substitution, vote for happy face emoji. Comment a happy face emoji. If you think that C is a elimination reaction, vote for a crying emoji, chat. Okay, and so let's go ahead and go through that together. Let's go ahead and go through that together one more time. So chat, what's the first step? Hopefully, if you've been here for the past hour, hopefully you understand what we do now. So what's the first step we got to do? What's the very, very first step we have to do, chat? And lock in together, twin. So this is our bromine. And then this is our substrate. So is this primary, secondary, or tertiary? Is this primary, secondary, or tertiary? We got lots of happy faces. We got lots of happy faces. Okay. So leaving group leaves, all right. But we gotta carefully. Okay, I like how some people are like jumping to the mechanism, but we don't even know which mechanism it is yet. Very good. Now we're getting. So we got tertiary. So Chad, do we understand why this is tertiary? If you understand why this is a tertiary, put a 3 up in the chat. If you understand why this is tertiary, put a 3. If you do not understand why this is tertiary, put a crying emoji down in the chat. Okay. So guys, there we go. So we got tertiary 3, 3, 3. Wadu says 3. Orgo exam tomorrow, literally. Okay. So I don't see any crying emojis yet. So if anyone sees any crying emojis and you understand, you can reply to them and help them out. Okay. Boogie says I know nothing, bro. So chat, this is gonna be a tertiary because I see 1, 2, 3. All right, very good. So this is gonna be a tertiary carbon, alkyl halide rather, and then we have MaOH. So this is the hard part for everyone because everyone is really confused. How do I know if this is going to be a nucleophile or a base here? So once again, chat, let's draw the analogy here one more time. So we need another crush because we can't be simping over Madison Beer. So I need another celebrity crush. Who's your favorite celebrity crush, chat? And we need like a Riz person. Okay? So this is our celebrity crush and we need someone who's going to Riz. So who's going to be the Riz? Like the person that's going to Riz up the crush. Jenny Kim. Martin. Yo, Martin. Pause. Martin. Good to see you, bro. Yo. Everyone's saying me, chat. Okay, this is going to be Dr. Drew. So, and then this is going to be you, chat. So everyone is saying that I'm the huzz today. That's fine. And then Kanye West. Wait, what? Kanye West is trying to Riz up Dr. Drew. Chat, pause. Come on. Chat. All right. So Kanye West is going to be coming in here. But look, check this out, okay? I got 3 bodyguards because I'm tertiary, okay? So I got hella bodyguards here. I got 1, 2, 3 bodyguards here, okay? Because I'm tertiary. So I'm safe, chat, right? Am I safe or am I cooked? Am I safe or am I cooked? Okay. I'm not gonna front. I'm not like I don't hate Kanye, but I'm not like the biggest Kanye fan. You know what I'm saying? Like I like his music, but like you know what I'm saying. So this is me, and then I have 3 bodyguards because I'm tertiary. So that's why I have 3 bodyguards. So Kanye, do we agree? This is never gonna be This is never gonna be an SN reaction, right? Because how is he gonna go out the back door? Because we have all these bodyguards here. There's nowhere for him to attack. So this is never going to be a substitution because where is he going to go from the back? There's no back door. So this is not going to be substitution. It has to be elimination, chat. Chat, do we agree that this is elimination for sure? Okay, this is elimination for sure that this is going to be he can't go from the back door. If you agree that this is elimination, go ahead and drop that thumbs up. Okay? So now we know for sure it's going to be elimination. So what's going to happen? So now our methanol is basically going to come in and Kanye West is like really, really hungry. He's going to basically come in and steal one of the protons from the bodyguards. And then basically one of the bodyguards basically just, he lets me, you know, I got to think about the analogy, but I'm basically going to eat this proton right over here and then kick off the leaving group. And that's why we're going to have 1, 2, 3 double bond alkene just like that. So now I'm cooked. So now me and Kanye are going to, you know what I'm saying? Like we're best of buddies now. Okay. So guys, but this is going to be our E2 mechanism. The E2 mechanism. This is a tertiary tertiary alkyl halide generates a secondary alkene. Okay, secondary alkene. That was a fun one. I wasn't expecting to be in the show today. That was a fun one. Does solvents matter? Yeah, we have MEOH. Okay, E2 major. Yep, 3' always E2. Okay, once we form an alkene, it's an E2. Once we form an alkene, it's E1 or E2. Okay, once we form an alkene, it's E1 or E2. E2 means alkene means it's E1 or E2. E2 is only for concerted. Okay? E2 is only for concerted. E1 is for stepwise. E1 is for stepwise. Okay? So E1 is for stepwise. This one was not E1. Okay? E2 is for concerted. So every time you see an alkene double bond, always think elimination. All right? Yes, we're gonna assume methanol acts as a strong base here. Okay, chat. Let me know if there's any questions here about Kanye West trying to rizz up Dr. Drew. So strong base E2, E1. What solvent is associated? Smiley. Which textbook, my friend? Is that Solomon's or David Klein? Is that Solomon's or David Klein? Most likely not. So guys, this is gonna be our table. So once again, if you want the table, just DM me for the notes, okay, or join the Discord for the table. So if we have a base only, okay, it's gonna be E2 no matter what. Okay, so if it's gonna be a base only, it's gonna be only elimination here. So that's why it's gonna be E2. It's not gonna be E1 because we don't have any additional reactions here. Okay, so guys, keep practicing that out. We're gonna be on. Let's do one more. Let's do one more and then we're going to call it for today. But don't worry, I will be back tomorrow. And guys, we're going to do one more today, chat. And then I'm going to drop all these answers in the book. This is going to be our last one. And then I'm going to post this up on my YouTube channel. So thanks so much for joining the live. Sign up for tutoring, link in bio. And then chat, this is going to be our final one. So one more time, I need a Riz analogy, like someone who's going to Riz up someone. And then I need a huzz. I need like, who's our celebrity crush? So drop your celebrity crush and then drop your favorite person that's gonna rizz up our celebrity crush. Okay, so we have our, this is not gonna change. This is not gonna change. This is still gonna be tertiary. Okay, and then this is gonna be terp butoxide here. Okay, so who's our celebrity crush this time, chat? So who's our celebrity crush this time, chat? Okay, I can definitely check Smiley if it's in Solomon's. What number was that again? Smiley, let me know what number was that, and then I can answer it right now. We can check that out. Okay. Billie Eilish. Okay, Billie Eilish. Yeah, Billie Eilish. Billie Eilish. All right, perfect. So that's gonna be who we're trying to rizz up, and then someone says that they're gonna, and then John Cena or Gru. Okay, Classy said Gru first, so we're gonna say Gru from, is that Gru from Despicable Me? Okay, so Gru is gonna represent, that's actually perfect. Good job, Cassie, because guys, Gru is a really big character, right? So let's draw Gru as like really big. Okay, Cassie is cooking today. So Gru is like really tall, right? He's really bulky. So Gru is really bulky here. So that's going to represent terp butoxide because terp butoxide is really bulky. Okay. So therefore, Gru is going to come in. This is Gru. Okay. And then how many bodyguards do we have, twin? We have 3 bodyguards. We're going to have 1, 2, 3 bodyguards. So Gru is never going to go in from the back door because Gru is terp butoxide. Okay, so Gru can't go and sneak in on the back side because, so SN is not going to be possible. Okay, SN reactions are not possible because Gru is way too big and Billie Eilish has 3 bodyguards. Exactly. Kelvin said no back. Okay, I'm not going to repeat what Kelvin said, but exactly what Kelvin said is true. Yeah, that's his head. His head is tiny. Okay. And then chat, I'm getting this. Classy is cooking. Yeah, there you go. And then there you go, guys. So it's gonna be E2 again. So how's that gonna function? Remember, you need to memorize terp butoxide looks kind of like this. Okay, terp butoxide look kind kind of strange looking. It does terbutoxide does look a lot like GRU, doesn't it? Oh my gosh, that's crazy. Terbutoxide looks a lot like GRU, and then GRU is gonna come in and demolish one of these protons and generate an E2 product here, just like that. It's gonna be 1, 2, okay, just like that. It's gonna be E2 major product. So it's gonna be E2, not substitution, okay? So there we go. Chat, this was a lot of fun for me. I don't know about y'all, but thank y'all so much for joining into the lives. Hope everyone crushes their exams. Guys, anyone that's new here, my name is Dr. Drew, PhD in Chemical Engineering. I go live every single week, Monday through Thursday, to help you lock in for Gen Chem, OChem, Math, and Physics. And Kelvin says I got 108. Oh my gosh, cooking. Thank y'all, my friends. I hope y'all cook. So let me know when's your midterms. Let me know when's your finals. Once again, I'm going to be posting this up on the YouTube channel later tonight. But guys, best place to find me is, well, right here on TikTok, okay? Or on my Instagram. You can follow me on IG, TikTok, and my YouTube channel. Let's see. I want to hide this. Let's see. I want to hide this real quick. So guys, if you need any tutoring, I got you for Gen Chem, Math, OChem, Physics. Okay, go to engineeringminds.co, tap that link that says book tutoring. The first session is 100% free. I've helped over like 25 students in calculus, physics, general chemistry, organic chemistry, and recently I started doing fluid mechanics and thermodynamics. So shouts out all the chemical engineers in the chat if you need thermo or fluids. And yeah, guys, join the Discord. It's 100% free. Just tap that link that says Discord. And then select the reason why you would join. Community to connect with like-minded students and new friends, study tips, access free resources and tutoring discounts. Click on next, and then just let me know your email. You're gonna check your email and you're gonna get access for free. And then you can also do the resources. So recently, anyone that's taking OChem right now, I recently posted the chair. So anyone that has to review chair confirmations, let me find that real quick. Where's my chair confirmations resources? Okay, I don't know where the chair one at, so I'm gonna make sure to make that public here. So the chair one is gonna be up there. We also have Gen Chem, so anyone that needs any Gen Chem, okay, there's gonna be practice problems there as well. I'm trying to basically I'm basically inspired by Khan Academy and organic chemistry tutor, but I'm kind of doing it more engineering-y. And so guys, we're gonna have like calculators, physics equations, and all that jazz. So yeah, guys, hope this was helpful. I will be back tomorrow at about 6 or 7 o'clock PST to continue the live stream. We're gonna keep doing Gen Chem and OChem this week. Ugo says alkynes next. Ooh, alkynes and alcohols. Yeah, guys, please let me know which topics you want to see. Okay, just DM me the topics here. Okay, and let me know what y'all want to see next for the next live stream. Mass spec. Okay, Classy says mass spec. So yeah, just let me know. Thank you for the rose. Oh, shouts out anything speaker. Shouts out anything speaker. Thank you for the rose. Make sure you buy your anything speaker. And yeah, once again, guys, first session is free for tutoring. Again, that's gonna be Gen Chem, Organic Chem, Mathematics, Calculus, and Physics. All right. So yeah, just let me know. I'm gonna be on for like 5 more minutes just to answer any last minute questions. If people have any like last minute, like if you need any like tips, guys, once again, I'm trying to build out the community. So the Discord is highly respectful. I make sure to mod it very carefully. Everyone's really supportive. So if you need motivation for studying, that's gonna be the best place to get motivation. Okay, we help each other lock in and support each other by answering questions, answering comments, and helping each other for those tough STEM classes. Okay, so I'm seeing lots for SN1, SN2, E1, E2, alkynes and alcohols. All right, perfect. Mass spec. Cool. I'm gonna write all these down. And then post the YouTube video tonight. And yeah, my friends. So if that's pretty much it, once again, I'm gonna end it for now. But I will be back tomorrow right around the same time. So make sure you hit that follow. And yeah, best of luck on all your midterms and finals, my friends. I will see you tomorrow, my friends. Peace out. Thank you all. Thank you so much. Good night.